Welcome to Microsoft Excel with EJD. In this video, we're still talking about the analysis ToolPak, very important for statistical analysis in Excel. In this video, our focus shifts to Z-test with analysis ToolPak. Okay. Again, in the statistics playlist, I've talked about the Z-test a whole lot, talking about the math side of things. But here, look at let's look at how we can go about it very easily with the analysis toolpak. Of course, the Z-test is a fundamental statistical test used to determine. So Z-test is used to determine, whether there is a significant difference between a sample mean and a known population mean and a known population mean. Okay. You have between a sample mean and a known population mean. That's one way. Of course, the other way is or you can say between the means of two populations, when the population variance is known, or the sample size is sufficiently large. Okay. I mean, the largeness here, the data set I used for t-test normally is expected to be can be considered to be sufficiently large, but I just went ahead and did that because we'll still get results, right? But usually you want to consider the largeness of the data set. Now, how do you say something is sufficiently large in that sense? Okay, let's look at that. So it relies on the assumption. I mean, t-tests, we are talking about z-test. Z-test relies on the assumption that the data follows a normal distribution. Okay, so relies on the assumption of normal distribution. Okay, we assume the data is normally distributed, or according to the what is called the central limit theorem. All right, the sample size is large enough. Large enough means the sample size is greater than 30. So the data set I used for t-test, t-test usually should go for data less than 30. Say any data up to 29, not any data from 0 to 30, in fact, is good enough for t-test. But once the data is 30 upwards, we can use Z distribution, right? So I did what I did the other time is still okay, right? But usually the data should be less than 30 for t-test to go for it. So that's what this assumes. So when exactly do you use a Z-test? So when to use Z-test? When to use Z-test. Okay. So there are a couple of situations where you can use Z-test. So you want to use it to compare a sample mean to a population mean when the population standard deviation is known. When the population standard deviation is known. In the case of t-test, right, there's no population standard deviation is not known. We're only assuming things like homoscedasticity and heteroscedasticity, talking about whether the variances are the same or not. When the population standard deviation is known, okay? So here we assume that the standard deviation is known, okay? Having taken care of that, which other situation should you use it? So you also use it when you want to compare the means of two independent samples. I want to compare the mean of two independent samples. Okay. When population variances, when population variances, when population variances are known, okay. Population variances are known and samples are large, and samples are large. In fact, this is the one Excel actually supports. Okay. This is the one Excel supports basically. Okay. All right. This third situation when you should use Z-test is to test hypothesis. If you want to test hypothesis about proportions, you use Z-test. So you want to test hypothesis about not about means, not about proportions, you use Z-test. Of course. How do you use Z-test? Of course, I think that it's now time to go on and talk about how to use Z-test practically. So let's open an Excel sheet which has been prepared for this situation. Imagine that you run a marketing agency, right? And you run campaigns for people. You have two types of campaign. You have campaign A and campaign B, and you measure the click-through rate for each campaign. I mean, let's say it's a YouTube campaign or an online campaign, and you get to measure the click-through rates for each of the campaigns. So you do the campaign for like 50 customers, right? So that's why we have campaign customer 1 to customer 50, and then you run campaigns A and B for them. Of course, with known variances. This is the second situation where we talk about second situation where you use the Z-test. That's when you're comparing the means of two independent samples when population variances are known and samples are large. All right. So in this case, we have 50 samples that can be considered large in the context of central limit theorem. And you can see we also know the variances for the two campaigns. So in this case, this actually qualifies for a Z-test for sure. Okay. So what do you do? Of course, first of all, for you to be able to do this, you want to check under data. Do we have data analysis here? Yes, we do. What if you did not have it? So what I'm going to do is I'm going to remove it and put it back so you can know how to get it there if it's not there actually. So go to File, come to Options, then click on Add-ins, and then come to Manage Excel Add-ins. Click on Go, uncheck Analysis ToolPak. You know, it's here right now. If I click OK, it disappears. So if in your case, you don't have the data analysis stuff here, the analysis ToolPak, that means the analysis ToolPak add-in has not been added. It has not been activated. So you go back to File, come to Options, click on Add-ins, then come to Manage Excel Add-ins and click Go, and then Analysis ToolPak. Check that and click OK. Now it's back here. So with this now, you can carry out your analysis. So this has met the condition that you have large data sets, and then you also know the variances for the two types of campaigns, based on the data set you have from the 50 customers, right? So for each customer, you run the two campaigns and you have this data from those 50 customers. So what do you do now that you want to run just like I said, Excel only supports that second situation. So I click on this now. All right. At least to the best of my knowledge, let me put it that way. Let me not be absolute. So you have two samples for means. That's the second situation. You have two samples for means. So you have campaign A click-through rate and campaign B click-through rate. And then those are the two samples, right? So what is variable one range? Mind you, variable one range, that's campaign A click-through rate. But make sure you don't include the variance. You stop at C51. The variance is not part of it. The variance is useful very soon you're going to see where the variance is useful. So that's variable range 1. Variable range 2 is the campaign B click-through rate. All right, you go this way. Campaign B click-through rate this way. Okay, make sure you don't include the variance also. Of course, you can even write the variance apart so that you don't get confused and include it. So I've bolded it so you don't go that far. Then hypothesize mean difference. Of course, the null hypothesis is that there's no significant difference between the means of campaign A click-through rate and campaign B click-through rate. Then variable one variance, we know that to be 0.0362. Okay. Okay, I guess we need to type it there. So that is 0.0362. Okay, that's variable one variance. Variable two variance, which is also known, is 0.0178. Okay, you can calculate it for sure. 0.0178, like that. Then, of course, the first rows, there are labels. Then the significance level is 0.05. Or is this the what's this called now? I think it's called the significance level. That's alpha, right? Okay. And the output range, where do you want it to come? So we have this up to ABC. So we can put this at E now. So I click on this now and I just go for okay, of course, lock it down, $E $1. That's where we want our result to come. And in one blow, we have the result. I click OK, and the result will have appeared. Yeah. So we have the results split out this way. And then, of course, you can do a bit of formatting for the result to be a bit more readable. So let's come here and then go home and centralize this. Okay. Now, the mean click-through rate for campaign A is 3.3864. For campaign B, it's 2.801. The known variance, of course, we have those values. The observations, 50 each. Hypothesized mean difference is 0. Z value, the Z value is 17.81, blah, blah. Then probability for one tail. Okay, yeah. Let's see, how do we actually read this result, right? First of all, this Z statistic you see here, which is 17.81 something, this value measures how many standard deviations the sample mean is away from the hypothesized population mean. All right. So that's from 0. Now this is 17 standard deviations away from that. And then the p-value is the probability. So this is p-value for one tail. One tail is when you're saying less than maybe mu1 is less than mu2, or mu2 is less than mu1 is greater than mu2. That's one tail. Two tail is when you say mu1 is not equal to mu2, basically. So those probabilities are simply 0 here, and the critical values are 1.6, 1.9. So automatically those p-values are less than the critical values. But so the p-value is the probability of observing the test statistic as extreme as or more extreme than the observed value, assuming the null hypothesis is true. And the critical value, these two critical value for either one tail or two tail test, the critical value, they are the cutoff point that defines the boundary for rejecting the null hypothesis at a given significance level. So because 0 is less than this now, of course, you accept the null hypothesis. But if the p-values are bigger than the critical values, then you have to reject the null hypothesis. So at a given significance level, our significance level here is 0.05 that we saw there. So in conclusion, if Z statistic, okay, this Z statistic now is greater than the critical value. Oh, okay, this Z statistic, if it is greater than the critical value, or the p-value, this p-value, all right, so this p-value is less than the critical value, all right, so we can then, our p-value is less than the significance level. So our p-value is 0, right? And it is less than the significance level, obviously, which is 0.05. So we can reject the null hypothesis. So otherwise, we fail to reject the null hypothesis. And this interpretation can be quite confusing sometimes. But here, definitely, the Z statistics is 17.81. I guess you need to be cautious about the t-test also. You need to interpret correctly. I'm not sure. You want to be cautious about the interpretation of that. It can get really confusing. So in this case, now the absolute value of Z statistics is 17. The critical value is 1.6. So, and obviously, the Z statistic is greater than the critical value. Definitely. So as a result of that, we reject the null hypothesis that there is no significant difference. So that means that there is significant difference between the means of the campaign A click-through rate and campaign B click-through rate. So I might have misinterpreted some of those things under t-test. So be cautious. So interpret the results accurately. I think following this kind of pattern, that actually should help. All right. So that is what we have in this situation. So the practical applications there, yeah, quality control, you can apply this in quality control, in manufacturing. Okay, let me go back here so you can see what I'm talking about. So let's talk about some practical applications, right? Applications, you have applications of Z test in places like quality control in manufacturing. Okay. You have, if you want to compare performance metrics like average sales or test cost to a known standard. So, uh, okay, let me just talk about comparing performance metrics. Comparing performance metrics. Performance metrics. Okay. You use Z test in that situation. Then you can also use it for survey analysis. Survey analysis. Okay, of proportions, such as estimating population support for a policy. So you can use Z-test. So what are some advantages of using analysis toolpak for Z-test? Of course, you have things like automation, which avoids manual calculations and reduces human error. You have speed, which because it's quickly processing large data sets. Outputs, which provides clear, organized results, including test statistics and p-values. You have accessibility, because it is built into Excel, widely available and easy to use for those familiar with spreadsheets. Important note, the Z-test assumes the population standard deviation is known or the sample size is large. So for small samples with unknown population variance, a t-test is more appropriate. So if you have data set less than 30, like I said, you go for a t-test. But if you have data set greater than 30, you go for Z-test. When I did t-test, I used 100 data points. That's like overkill, but it's okay. But just know that the rule is that once you have data set less than 30, you go for t-test. Greater than 30, you go for Z-test. Then you also need to ensure that data meets assumptions of normality or use sufficiently large samples for valid results. Okay, so that's about this particular video about Z-test with the analysis ToolPak that we have done in this case. Let me know how helpful this is for you. And if there's something you'd like me to try out, feel very free to let me know. If you have not subscribed already, you're missing a lot. So go ahead, subscribe, hit the notification bell so you can always get alerted each time a new video is released. Of course, you can become a member of my channel so that you can get some special privileges. If you don't mind, feel very free to join. Ultimately, be sure to like, share, comment, and let's build this community together. This community of learning. Let's build it together and keep enjoying the great knowledge we share here. Till I come your way again, keep doing data right. Bye.